today we're going to talk about multi-input single-output systems. Now, these are called MISO systems, and they tend to represent what we would see in real engineering, where you have multiple factors that can change the output of the system you're looking at. And up till now in class, we've dealt with single-input, single-output, or CISO systems. And these are systems where you have an input and an output, and if you take the input and you say the transfer function will be the output over the input, then you'll have some function of S which will be a comparison of polynomials of S, some sort of combination of S and constants that will give you your transfer function. But what if your output is a factor of multiple variables? So let's say that we have y, which is dependent on a function of x and a function of w. So if you think about driving on the road, you have to think of both the system of the friction of the road that you're driving on, as well as any drag or wind. So multiple things can affect your system. Now, the way that we'll do transfer functions is going to be very similar to how we would do a derivative. So if you took the derivative of y with respect to x, you would say that the derivative of f with respect to x is the derivative of f of x, and the derivative of g of w with respect to x is 0, because w is not affected by x, it is independent. So the derivative of y with respect to x would just be equal to df dx. Similarly, if we took the derivative of y with respect to w, f of x would be 0 because it's seen as a constant from the point of view of w. So if we want to find the transfer function of a MISO system, we're going to do a similar method. We're going to set all other inputs equal to 0. So y of s over x of s will be the transfer function if we wanted x of s of our input, and y of s over w of s would be our transfer function if we wanted w as our input. Because what a transfer function tells us is how our output changes based off of one input. And we're going to be satisfied with having that as our system.